Before we start on trigonometry, we want to make sure our calculator is doing the right thing. It's in the right mode. So if you look closely, it has rad at the top of mine. You might just have a letter, an R or a G. I'm going to look for the DRG button if you have a Sharp or another calculator, and I just press it until it comes up with degree at the top. Same thing for this one, the degree button, DRG, degree, radians, gradients. Now the Casio is different. You have to click on mode and just keep pressing it until it comes up with the 1, 2, 3 degree, radians, gradients. Press 1 and check it by pressing sine 30. You should get 0.5. Once you have that, once your calculator is in the right mode, then we're going to continue with the work. So all the formulas will be on the final exam. You've got all three right here. We always put the angle next to the sine, cosine, or tangent. The fraction is the sides. So the opposite and hypotenuse, the sides are the fraction. The angle goes on the left side. So first of all, we have to label the sides. We have three sides, opposite, hypotenuse, and adjacent. First step is find the angle. In this case, it's theta. First one I always do is opposite, which is across from the angle. Hypotenuse is the longest one. It's across from the 90-degree square. And adjacent is touching or beside the angle. So this one, find the angle. We never use the 90. Nothing here. This is our angle. So hypotenuse is the longest. Opposite is across, adjacent is touching the angle. Next up, find the ratio. The ratio isn't a sine, isn't an angle. We're just going to take cos 13 and type it into our calculator. We always do 4 decimal places. And the fourth one, we look at the fifth one, we round up. Tan 47. And it's 3, but we round up, so 724. So the ratio is just 4 decimal places. We keep the 4 decimals to be accurate. Now, finding the angle, we have to go backwards. We know the sides. We need to move the sine to the other side. The opposite of sine, sine inverse. So B will equal sine inverse. And we type this into our calculator. If you have a one-line display, you have to do the division first, get an answer, press equals, then second function sine. 2-line calculators, second sine, you'll see the -1, bracket 13 divided by 34, bracket, and we get our answer. So all answers to 1 decimal place, round up to 22.5, all angles have degrees. So this one here, I'm going to do tan inverse on both sides. Ones here, we have to solve. We know the angle, so it's different from these ones. We're going to use algebra. And so when the unknown's on bottom, we're going to do the shortcut and just reverse them. When you switch them, the sine and 82 stick together. They're glued together and come to the bottom. And I just type in 34 divided by sine 82. This one here, the unknown's on top, which makes it easier. So we're going to multiply by 10, multiply by 10. This one here, the unknown is the angle. So I'm going to use cos inverse, the opposite of cos, on both sides. So I'm going to round up to 17.0. degrees. Don't forget the degree sign. This one, the unknown's on bottom, so I'm going to do the switch. and I get 130.7. Now there's no units in this question, so I have no units in my answer, but for triangles, most of them have the units with them. One, we're looking for the angle, so I'm going to use tan inverse to move it across, leaving the r by itself. So r is 75.3 degrees, rounding up to 1 decimal place. Okay, for the triangles, we have to go through all the steps. Step 1, label the sides. Don't skip this. This is my angle, opposite, hypotenuse, adjacent. Now, x is here, so hypotenuse, opposite has a number, so I need to find the ratio that has these two, opposite and hypotenuse. If I go back up, this one is adjacent, doesn't work. This one adjacent, doesn't work. The only one is sine. Start with the formula. Replace all three things, the x, 17, and 18 degrees. The angle always goes with the sine. The sides are in the fraction, so it's 17 on top, x on bottom. And from here we just have to solve it. The unknown's on bottom, so I'm going to switch these. 17 divided by sine 18 degrees. The units are centimeters, so my answer must also be centimeters. And just to keep track, we always have one angle. We already have the angle. This must be regular units. Same thing for this one. Start with the angle, label the sides, and adjacent and hypotenuse. The only ratio is cosine. Now the unknown is on bottom again, so we do the switch, and we get 64. And the units are feet, so I'll add that in. So remember the 3 steps. Label the sides. Don't skip this step. Figure out which formula that uses those 2 sides, plug the numbers in, solve. So now we'll go to the back side of the worksheet. I'm going to focus on this angle. I need to find this angle. Right there, I'm given 2 sides. So the same thing as the other side. We're going to label the sides and choose our formula. Now the formula for adjacent and opposite will be tangent. And I'm going to put the opposite on top, adjacent on bottom. Because the unknown is the angle, I'm going to use tan inverse on both sides to cancel it out. And I get my angle. Same thing for this one. The angle is up here, opposite, hypotenuse, adjacent, and I want the formula, the ratio for adjacent and hypotenuse. Cosine, adjacent on top, hypotenuse on bottom. And use cos inverse to move it over, leave the p where it is. And because it's 0.95, I'm going to round up to 66.0. And I do put the 0.0 to show that I've rounded to 1 decimal place. So, word problems. Some things to remember. First of all, we measure what we can touch. We don't usually measure through thin air. So if there's a string, a ladder, or the ground, we measure along those objects. If we measure between objects, between me and a house, me and a tree, I always measure along the ground, horizontally, never the hypotenuse. And if I'm dealing with angles, and if they talk about elevation, inclination, depression, it doesn't matter which one it uses, it has to touch the horizontal line. Because we can draw the triangle upside down, the key thing is don't even look at the word, make sure it touches the horizontal line. So, always start with a little diagram. I've got Carl wants to measure the height of a tree. He is sitting 8 meters away from the base. So the base of the tree is the bottom, right there. Carl is over here, and he's 8 meters away. So we always measure along the ground. He measures the angle from the ground to the top of the tree to get 56 degrees. Now he's measuring, he's standing here, so the angle he measures. So now we can solve the problem. We've got 2 numbers in our diagram. Label the sides And so the height of the tree is the opposite, and we know the adjacent. So I'm going to put the opposite on top. We don't know it. The 8 meters is the bottom. Unknown's on top, so I'm going to just multiply both sides by 8 meters. So the tree is 11.9 meters. Always one decimal place, include units. Okay, so a kite is blowing in the wind. The string is 23 meters long. So I'm going to start with a kite, draw the ground. Now the angle of inclination is 45 degrees. I have to touch the horizontal line, 45 degrees. I need to have a 90-degree angle, and the string is 23 meters long. So the string is right here. I can touch the string. I'm going to put that in there. So once I've got that, I'm going to label the sides and choose my formula. I have the hypotenuse. I want to know how high is the kite. Height is the opposite, so hypotenuse and opposite is sine. The unknown's on top, so I'm going to multiply both sides by 23, and I get 16.3 meters. So the kite is 16.3 meters high.